Hello ladies and gentlemen, boys and girls, my name is OctoMan and today we are taking a look into a endless runner with a ski or snowboard theme. That means I'm gonna introduce my concept which I draw or have drawn quite some time ago. I'm gonna introduce that in one moment or two. Before I do, don't forget to subscribe to the channel if you haven't already and you want to see more content in the future, as well as don't forget to ring the bell, like activate the bell icon so you get notifications about new live streams as well as anything else over there. So we are going to start with a complete empty project over here. This is going to be once again in a prototyping scenario, which means I'm gonna put this prototype sooner or later probably onto my website, especially if you want to purchase that so you can get the final result at the very end of this live stream, or at least go later on into this onto my website octomangames.com and purchase it over there if you're interested into it. So probably which I usually do is I'm gonna put some more extra work into the prototypes I'm creating. Also the live stream from yesterday was Choo Choo Rocket. I'm gonna put this one onto my website there as well, which I already fine-tuned a bit. I introduced cats and stuff like that. It's going to be purchasable sooner or later on my website. Just check it out later on. I'm gonna go later on and talk about this. Okay, so let me introduce my little concept about what we are going to do today, or what I try to achieve today. So a while ago I was painting this concept over here. The concept is that you're gonna have a figure or a creature or a person or a whatever, a dummy, which is going to be a ski driver. On the left and on the right side on screen you're gonna have like limits where maybe you're gonna put people there, like, you know, something which are just saying hey you, whoa, whatever, and the goal is to go a route which is considered or actually defined by flags. So there's a flag to the left, there's like it's showing with the flag to the left, then it's showing with the flag to the right. Also there will be other ones which you can pass through. At the same time, there are probably other ones which you can duck through, like you have some special input. Not quite sure how to do this, but that was an idea to get some extra points. So every time you drive around one of these flags, you're gonna get score. How do we do this? Well, we just put a collider or something like that. We'll talk about this. We could also shoot a Raycast through the area from these flags and then see if somebody is passing by. So we're gonna start somewhere here, and depending on how we want to handle this, we can let the figure stay at the very top, or bring that one a bit downwards, depending on how we want to do this in the end. I want to make sure that I cannot pass the outer rim over here, and also I want to give something like, hey, you missed a flag, so probably you can miss a total of 3 flags, and then the round literally is over. And meanwhile you are driving down, we could go and think about increasing speed over time, something like, hey, or maybe speed over flags you have passed. So these ones are must-have flags, I guess, and these ones here could be special flags. Maybe this one not, but you should avoid going around that over here. Same thing is, if we would go for mobile, we could think about using a touch input. Literally, it's just a left mouse click held down on the screen, and so we can, you know, define that. What we can also put in on this route is some gimmicks, like a present which can give you something like extra scores, some gold points, whatever you name it. Probably something else like somebody lost his trousers, or maybe you're gonna find some coins to pick up on the route. But also we can put in some rolling snowballs which can come from the upper side over here to damage the or well, not damage, but make them slower, or maybe I don't know, maybe steal or flag, something like that. So we have a bunch of possibilities. We can put in some bear traps. We can put in some snowman on the track as well as being an extra obstacle to avoid. So this is basically what every or most of these endless runners do. You're gonna avoid things. You have life. You collect stuff to get more score, and every time you do this, every time a round probably has ended, the score is literally like a value or something which you can purchase. Let's say new things like maybe a booster, maybe you can unlock something. I don't know. I haven't thought about this value thing over here. First off, I want to get all the mechanics done. And the mechanics usually work the way that we are instantiating those flag things, and then we're gonna make them move upwards. So literally the player constantly stays at the same spot, but the flags are going to be the ones which are moving. We can think about of that. Also, we can define it so that the background is going to move as well as the people are going to move as well. So we have like a an infinite rolling upwards. If we want to make something else like curves, we can put them in here. We just need to have a tile set, I would say, which would introduce or which would make it so visible, literally. And also we need to put the colliders at the corresponding spots. So, if meanwhile you're watching this live stream, feel free to ask any question you may have, even if it's not directly relative to this stuff we are going to create today, or I'm going to show you how I would tackle this issue, this problems. We have a bunch of problems to solve in this live stream. So once again, feel free to say hi or just ask questions if you have any specific ones. Okay, so this is going to be, you can make this in 2D, you can make this in 3D, nobody cares. Well, I don't, and you shouldn't as well. I usually go with 3D because I like to work with 3D more. It's more appealing to me. Okay, so I hope you get the idea so far. What I want to go for is now, and this is the first thing. I always load my layout I have prepared quite some time ago. So I have my inspector here, my lighting tab, my sample scene is set up, I have my main camera, my directional light, and I have an assets folder. So today I haven't completely created any 3D assets, so we're gonna have to put something together which is going to do the job for us. So depending on how we want to see with the camera, we can go straight, but we can make the camera show like top to bottom, or like top to bottom over here, or a 45-degree angle, doesn't really matter. So first off, we need to define what the player could be or look like. Usually it's just an empty, where all our, let's say, controls are going to be on. And then we have the visual like the knees, the legs, whatever. I'm gonna put something with boxes together today. So we can probably use some, what is it called? IK, I don't know, maybe not. Since I want to keep it as short, but as informative as possible. So let's assume we create a new player, empty game object, nothing is inside, it only has a transform. Over here I go and reset it to be 0, 0. We can double click to go closer to it. So this is nothing but an empty. What I want is, since I later on want to check if I collide with something, that's the first thing I want to do, is probably put a collision object directly as being the player. So probably an empty is not the right way. Let me do it different. Let me create a cube, which is going to be my player. So what I do have is automatically a box collider as well as a mesh renderer. I can disable this mesh renderer later on if I don't need it. I'm gonna reset it still in position XYZ, so we can still play around with these. So next one is if we want to go and make a player visible, we can put him on a snowboard, we can use roller skates, we can use literally any theme you can think of. So it's not needed or necessary to be a ski driver, or it's not necessary. It could be even a biker, it could be a car, it could be a minion, it could be literally anything you can think of. It could be really any 3D object you think, which could be nice. Could be even Red Hood if you want to. So this player now needs several things, several objects. So first off, I create them, just rather simple ones, no issues with that. So I need a head, like a sphere. So this has the same scale as my player object. I'm gonna put the head, I don't know, maybe here. We want to make him look sporty. Once again, in prototyping, it does not matter how things look, not much, I would say, as long as it looks, let's say, appealing. So I need a pelvis. So I create another 3D object. Let's take a cube. Gonna scale this one a bit together. Maybe like, I don't know, so. So this is where the butt is going to be at the very, you can also use two spheres to make it more, I don't know, appealing. And from this cube I need a leg and then another one just to have the look of a leg. So if you want to, you can rename those things. If you are a 3D artist, you can also think about creating a full character, of course. I don't like to do it today because it's a lot of work actually. On this pelvis, since it is scaled now, I want to do this first without putting it over there. So I want to create a leg, and I want to put this next to the pelvis over here. So it has to be slim, and slim here as well. And it doesn't matter where the actual rotation point is, like the ankle. So everything should be fine. I'm gonna choose not local but global, so I can easier manipulate those things. If I want to, I can go and scale this one a bit more here, something like that. So just to form some kind of a leg over there. Again, you can do this however you please and like. Again, if you have any questions, feel free to ask. I need to duplicate this one, and since I have another side on the bottom, once again you can be as creative as you like with these things. Gonna duplicate this once again, and literally I need a zero one. I'm gonna scale this. I need some shoe or foot. Gonna do a bit more scaling here. So we have a foot here. Pretty cool. Now we need a ski, or you can, once again, you can put him on a snowboard. It doesn't matter. It's just totally up to you. It's just a visual to represent a position or a size of an object, something like that. So I duplicate this one here again, make this flat, and scale this one up. So we got a ski something over here going on. Well, hopefully. So once again, we don't go into rigging or something like that today. We just want to produce. We just want to produce something which looks at least okay-ish. So once we now would link all these things together, this would need to be part of the foot. The foot needs to be part of that. This needs to be part of that. So linking backwards. This is called forward kinematics, if you get the idea behind this. So we take this one, which is the actual ski. Once again, you can model the stuff on your own. I'm gonna make it part of the foot by just making a child of it. Then I go here, which is actually not cool. Do us through the actual linkage there. Let's see why that happens. Oh, I believe it's because of a scale somewhere else. So usually maybe we should go with something unscaled as an empty. Hi Carlos, thanks a lot for tuning in. If you have any questions, feel free to ask. I create an empty over here. Maybe I can link this to there. No, I can't. Okay, never mind. We don't go over rigging as I said before, so it doesn't matter. We just want to make sure that all of these things are part of the pelvis. Okay, it was moving a bit, but that's okay. So this is like one leg. And if we Control D this one, we can copy this one over to the other side here as well. Now I want some other piece over there. I'm gonna go select this once again and create a new cube. Gonna put this where the shoulders should be, and gonna scale this one a bit here and there. If you want to rotate these things, you can do so, so it looks a bit more appealing, I would say. So as you can see, super simple shapes, nothing fancy, just put these things together. Once again, if you're a 3D artist, feel free to create your own nice 3D models. Now I'm gonna put an arm onto this cube, so this is going to be my shoulder piece actually. Shoulder, you can also name it chest, whatever. That's more than enough. We don't need a chest, a real chest. We don't need a belly or a neck or something. It's just, again, it's just going to be a representing, or it should just represent the stuff we are creating over here, like represented in a visual manner. So once we put that stuff together, I'm gonna put an arm. I try to, some kind of an arm. Literally doesn't need to be as precise as I said before. Like what we could do is we could just say we scale this one into any direction. We can also make it so that the arm is going to go, you know, like once here, and then we're gonna put the sticks there. Once again, I don't go over animation at all. Like we could do it also in this way. So how do we do this? Well, I don't know. If the head would be somewhere here, because we are rather quick, maybe I'm gonna put arms down there. I just rotate this one a bit more, and then I put the sticks back. I don't know, something like that. So simple shapes, once again, keep it simple, helps you out quite a lot. So I go with local movement, at least for the moment. Arms probably are not as huge. No idea why this is rotated over X. Oh, never mind. Gonna copy this, Control D for duplicate. Gonna rotate this one like here. So again, we don't even need hands. It's just, again, it's just a visual representation of what we want to create. So this is going to be the arm part. And now we're gonna put a cylinder on the shoulder here as well. You are create cylinder. It's rotated. All of these things do have colliders, so usually we should get rid of all these colliders later on anyways. I scale this one pretty much together, but make a rather long scale. So these are like the sticks you can you will have in the hands. Maybe we make a little sideways rotation. Again, we shouldn't care about these colliders. We can get rid of the capsule collider, just remove it. Since the weird scale over here, so I'm gonna put a 0.2, something like that over X and Z, which doesn't seem to be completely nice. Maybe something like this. So gonna take a copy of that, Control D, and bring this over to the other side. Oh, I took this piece there as well. which I didn't want it to. I don't know if there's a mirror command, but I guess not. Actually, I shouldn't use these. I'm gonna put them or connect them there. I'm gonna get rid of this and put this here on the other side. Maybe I should use a global movement and not global. And we rotate this with this stick over to the other side. Okay, I guess that makes our ski driver more than enough believable, I would say. So we got our player together. So we got this little point, which is the most interesting one. It's our collision whenever we or our checker, I would say. So everything is based on this checker. So it will get a trigger or just a collision, like a rigid body collider, but we don't move anything with rigid body. We just use left and right movement. All the other pieces over here, whatever they have, any kind of a collision object actually is not really necessary. We don't really care about them. But what we want to make sure is probably that we make them all. There's an empty we can actually get rid of. We can all make them all trigger collider. There's another empty, can get rid of this as well. Okay, so trying again. All of these can now be trigger collider. Same for the shoulder pieces, like all the things here, they can be trigger collider. Since we have cylinder here, they use different colliders. They can't contain any anymore. And same for the head. Just make it just in case. Okay, now we got this guy, and now we need to give him some movement left and right. This will be super unspectacular. So basically we just do this. Left, right, nothing fancy. We need some mouse input to do this. So we code in a mouse input. Whenever we do a drag, like a left click drag on the playfield here, we want to translate this one to the X and the X, only over X actually, at least for the moment. We want to translate the X movement to this player. And we want to make sure that he is not able to leave the game space, like the game field overall. Let's keep him here and let's take a look pretty quick to a playfield scenario. What I would go for is I would just stretch some pieces here over lengths. So these could be, let's say, where people are going to be about, or they're standing around over there. We can make that things high or not. Basically does not matter. It's just something which probably makes it more appealing. That seems to be a bit too high. So something like 50 centimeters, so 0.5 times higher. And I go in isometric view and try to reach the front here, so I can see where we are, or where I am here. Now we take the other side, Control D, and I don't know, bring this over here. So maybe we're gonna use a full 10 meters as being our playfield, and this is going to be our driver. Now for design cases, we could think about multiple things. First one is we can predefine prefabs which are representing specific scenarios. For example, one prefab, we can spawn multiple prefabs which contain, like, let's say here, a 20 by 20 playfield area, and we're gonna have the possibility to predefine what the obstacles or what the flags on this particular prefabs are going to be. Probably it's a bit too small. Maybe the game field would be too small. Let me try that out pretty quick. Maybe we go from the player's position half, like 10 meters, like 15 meters to the left, 50 meters to the right, something like that. So just to get a feeling of how our game could look. Same one, I try to figure out now where my camera could be, and I guess I could put it somewhere like this. So if I go to main camera, game object, align with view. So now we see the camera a bit different. I would also go with high, like with landscape, with a portrait mode. So something like a 9:16 or 10:16 aspect ratio. And what we can see now is, I go out of isometric view. The camera doesn't show everything, at least not at the moment. So meaning, if we go so far away, it shouldn't matter where we are with these tiles. But what we want to see is we want to see the full tile. Like if that would be one tile, like 10 meters broad, we want to see what's coming next. So in that case, we may go with the main camera and drag it a bit far away, or just a bit more far away. So we have more time as a player to react. Let's try and create one of these tiles. I would go with a plane. As you can see, a plane is 10 by 10 meters. So we just double the size of this. I'm gonna reset this tile, or this plane. And I'm gonna put this for the moment as a -10 over there. So I go over X and multiply it by 2. So I have a full size, I would say, as this one could be like a specific tile over there. Now what I want to do is I want to put these quads here, or these things. I want to make them like sitting in the center of that, and maybe make it so that they would fit the tile or the plane over here. If it is a bit more or less, doesn't really matter, I guess. We can make them later on visible or invisible, depending on what you plan to do over there. I get rid of that and create a new one. I want to make sure that I'm as precise as I can, of course. Later on, these are going to be our walls. So, I'm gonna name this one a tile. Gonna put these cubes as child objects to be part of the tile. Why is that so important? Once again, I can now place on some tiles. I can create empty tiles, and I can put flags on these tiles. If the size of 10 by 10 is not high enough, then I can go with the tile size and scale it up once by 2. So we have 20 by 20 tiles. We just need to remember how big the size is. So every time we create a new tile at a position, it's going to match next to the already existing tiles. So how would I build it up? Let's assume we duplicate a tile and we put them like next to each other, like so. You can see, if I do this with about 3 or 4, I'm gonna have a constant tile set, which is more or less fitting together. I can bring some more in-depth info about this later on. And what I can do is I can also bring this like under our guy here. We just need to think about how far or how much do we want to see afterwards, and what is about the camera. Is the camera in a good angle, in a good shape over here? So this camera currently, as you can see on the frustum of the camera, does not catch up everything on screen. So we might think about rotating it a bit, and of course bringing it a bit more up, like so. So we could see or expect or try to visualize what's coming up next. Again, we can think about this once. What I next want to do is I want to see my player better, since on a wide playfield, we don't see much. So in total, that means when you can see over here, when I would press play now on full screen size, we don't see much, but some shadows probably. We don't see that this one is going to be some guy, since we lost, actually we lost his bottom position over there. Fun part is we don't want this, but we want to lift up our player over here, so we see his ski at least. And now we can also create some materials to tint. Hi Erol, thanks a lot for tuning in. We can create multiple materials to make him more visible. So right click, we first off could create a materials folder if we want to. If you have 3D objects, you should literally do the same. Also inside over here, we create just one material. We can make it a blue, maybe a black, maybe different colors. I'm gonna duplicate this multiple times, and in here I maybe make a black. And of course I want to rename this. Press F2 to rename when you are sitting on a PC. I'm not quite sure about a Mac, because I believe a Mac does not contain F2 or F buttons. Just check it out. Maybe we need some else. Maybe some red. Yeah, why not? I go a bit more pastelic with the colors, like not too bright, not too shiny. We can also get rid of the shininess, like depending on metallic and smoothness color stuff. But again, that doesn't make any difference now. And what else? Maybe we need a green for flags. Would do the same. Would go for a pastelic tint, something like that. So we will create the flags in a moment, because first off we wanna visualize our guy here. So I would go and use black probably here for these things, so we can see them from the top pretty good. We can make him a blue hat or a red hat, and then we can tint all the body parts. Like literally all the cubes. I don't know if that works. That does work pretty good. All the cylinders as well as the shoulder. We can also define these sticks to be in any other color. Maybe green, I don't know, doesn't really matter, I guess. Or maybe red. Oh, why not? Okay, so let's go in full screen mode once again. The pelvis needs to be in a color as well. Looks okay-ish. I just need to go and bring back my black color here. Maybe we'll give him a black pelvis. I don't think that we are going to see this, but it doesn't matter. Looks okay for me so far. This white cube here, this what represents the actual player. We deactivate the mesh render component on this, so we don't see this rather in game or anywhere else. Now what we want to check is when I now move this to the right and to the left, that we see literally everything we want to see over there. Once again, we don't go and figure out animations in this piece because, well, it's not really necessary, I would say. Once again, guys, don't forget to sub up the live stream and ask questions if you have any. In the chat. Hi Unlegit, thanks a lot for tuning in. Hopefully you have had a good sleep last night. What's up? Well, today we try to make a ski kind of game, endless running. So we need some mechanics to get the endless stuff running. So for example, we need to define possible tiles to spawn at the very beginning. And then we want to move these tiles on this axis, like on the Z axis, like constantly forward until they, let's say, reach a point or a destination. and then we get rid of them, like we destroy them. But what we want to do is probably not destroy them. Maybe we're gonna use or take a look into object pooling today. Not quite sure yet. If you want to know what object pooling is, it means that we pool objects we have created already, so we can reuse them. So we just literally put them over here at this position, whatever it is, Z minus 40 or something, Z minus 40, yes. And then we pull them out of the already created pool. And if an object does not exist, we can still instantiate it. But once it reaches this position, which would be the Z-axis 10 or probably 20 in plus, then we're gonna disable this object. And later on, when we disable that, we can pick this and take this one once again outside of the pool and bring this back in the front of the if we decided, or if the system randomly decided to put this at this position over here. Okay, so let's get started with moving the player left and right, because that probably is the most important thing for the moment. So, and afterwards we go for tiles to actually constantly spawn and move. On the other hand, what we could do is we could start with that object pooling thing, or actually with just moving tiles. How to move things is pretty simple, but how to get rid of them at a specific point and how to instantiate new ones at a specific point is going to be another little thing to figure out. Okay, so I got the player and I want to have a script for the player to bring him left to right. So I create a new C# script and call this one player. You can name this one player input or player behavior, player whatsoever. As long as you know what this is going to do, you can go with it. I'm gonna put this player script directly on him. We don't use any rigid body stuff. We use plain movement. And to make sure that the player is not able to go outside of the rim over here, or outside of the boundaries of the game field, we have multiple possibilities. First thing would be, well, what could it be? Collisions. But the problem with collisions is that they start to flicker when you try to push an object through another. So what we probably use is, once again, raycasting. So we shoot a ray to the right, we shoot a ray to the left of the player, and once the ray hits a wall, we ignore inputs, like when we hold down the mouse on the screen. And that's going to be another interesting piece. Meanwhile, we are on screen and we hold down the left mouse key, or we do a touch input, so it's literally doing the same. We want to translate this movement left to right, like from a, let's say, point delta or something similar. We want to go left and right, depending on the direction where we started to draw, or to, let's say, drag with the finger. We don't go and use direct touch input, I would say, because it's literally the same as doing a hold down the mouse on screen and calculating the direction for him. Also, maybe, not quite sure, maybe we do some small rotations to make it a bit more believable when we drag left and right. We'll see. Once again, if you have questions, feel free to ask them at any time in the chat. I'm constantly watching it, so feel free to do so. Okay, so let's open the script. And let's take a look into what we need to do today. So first off, what do we need? We need input. We need a left and a right one. We need an on mouse held down thing. So meanwhile we hold down the left mouse button, we want to do something. To do that, usually we're gonna do that over using the update loop, because the update loop is constantly checking for inputs if we tell it to do so. Also, update loop runs 60 times a second, so it's doing a lot of stuff. So try to, or be aware if you are using the update loop. Use update loop once again only if you use or need input. So what we want to check is at first, if we are holding down the left mouse key, once again on touch input, it's a bit different. Then you need to do something like touch whatsoever. I don't know. I forgot about it. It's something with touch. Touch dot something. I don't remember. It's a finger something. Finger or index. Finger index touch input. I don't know. It doesn't matter. Or input dot touch. Whatever. So what we use the mouse input. So input dot get mouse button. Get mouse button. So if we use get mouse button up, it means we are releasing the mouse. If we go and use down, then it means we clicked it once down. And if we use get mouse button, it returns meanwhile we hold down the mouse button. So this is the one we are looking for. And then we need to define the mouse button itself. It's in our case the 0 one over here. I'm just reading your question, Unlegit. Can I help you? Well, rigid body player movement is a bit tricky, I would say. So when you move or use rigid body movement in any case, and it's glitching away, I recommend always use raycasting. So literally, depending on what the type of player movement is going to happen over there. So if you have like a left, right, and maybe up and down, then you need to shoot raycasts in 4 direction. Also, it depends if you are using an update or a fixed update, which is going to be a fixed update is used for rigid body collisions or rigid body movement, I would say. So instead of using update, you need to go with fixed update. It's called fixed. It's written like that, fixed update. There's also some collision things where you need to go into the settings in which you can define how high or how quick the collision should be checked and stuff like that. So I believe I got some input for that somewhere on my channel. I'm not quite sure, but that should be the work over there. I hope that makes anyhow sense. Okay, so for my player over here, we want to hold down the mouse key, and then meanwhile we do so, we want to see probably where we have clicked the first time, and then if we do a mouse movement to the left or to the right, like over X. So for that, it could be tricky sometimes. But what we want to store is the actual, let's say, mouse position. And then when we move to the left, we want to make it so that the player is following the mouse over its delta X or input X value. We don't care about Y. We just care about the X. So how could we do this? Whenever we hold it down, first off, we want to make sure that when we click it the first time, that we store the information we need. So for example, we store this in a vector. Well, it should be a vector too, since click input, mouse input, is usually only X and Y coordinate, because the screen on the camera literally is only sitting on the X or on the Y position. So let's name this one click position or something like that. We just want to store whenever we do the first click where the click position is, so we can do a comparison. Like if the current mouse position meanwhile we hold down is bigger or smaller than the click position, so we get the delta. So literally that's how I would try to solve the first issue over there. But we need to store the click position first, and this is what we do like with the first input. Let me copy this. And here we just change this one to be get mouse button down. So whenever we click once, we store the position of the input or the mouse position input inside click position. So click POS is equal to input dot mouse position. So this is going to be the first thing we do. We store the current mouse position wherever we have clicked. It's the same thing when we do finger touch stuff. It's basically the same. Let me try to explain this pretty quick because I got a request about this. I just make a small screenshot here so I can paint on screen. So bear with me. So how does it work? The camera has a 2D field. And we have here the Y coordinate, and here we have the X coordinate. So, and I got a request on a rather old video about camera touch input, where I used a 3D camera rotation over X and over Z, X and Y coordinate. If we have an object like a cube inside a scene, which rather uses X, Y, and Z value, so this is Z like the forward axis, then we need to translate when we do a rotation over X, when we touch the screen and we move our finger left and right, the game object here has to rotate over the Y axis as an example. Why? Because when we rotate the object around its middle axis, we're gonna do it over Y. So that is why we need to calculate this over here. Same thing for the Y-axis. If we have an object over there, like a cube again, and we do a touch input top to bottom, then we want to rotate the actual object or the camera, whatever it is, here over the X-axis. Because if we're gonna do a roll this way when we do the Y-axis input. So that's why we need to go over X when we do we rotate over X an object. It doesn't matter for us at the moment, but to understand, the screen itself is a 2D space and we gotta have the world, which is a 3D space. That's why we need to convert the X input into the 3D world from here. Have a good one, Unlegit. Talk to you later, probably. Goodbye. So we're gonna have the mouse input right now or actually we store this information. Then we need to go and drag or keep dragging based on and check if our current mouse position is bigger than click position X or smaller. Also we need to define a speed, but what we want to do is we want to move based on this knowledge. We want to do a check. So there is let's say there's one issue with that. It's like a black hole, because there's probably some position where there's no input, because probably it could be bigger or smaller, but not directly the position where we have where our position is. But doesn't matter. So how do we translate this information right now? First off, we want to check if our click position X, if that click position X, let's do it different. Let's do the vice versa. If input dot mouse position, not mouse, but mouse position dot X, if the input mouse position dot X is smaller, we could also say smaller or equal, but it doesn't make sense, smaller than our click position X, then we want to do a movement to the left. Move left. And we want to do the opposite when we do this over if the number, if position X is bigger than the click position X. We need to do it like that. So in here we want to do move right. Well, that's what I expect. Also, we may want to set a boolean to be able to move based on the frames on the left and to the right. The frames, I mean this borders, which we only are able to input whenever the raycast, we haven't introduced this one yet, to the left or to the right does not feel or touch a wall. I hope that makes sense. So, and depending on the ray length, we can define how much space we want to keep on or having to the left and to the right with these raycasts. Okay, so when we want to move left and right, what do? We translate our current transform position. And what do we want to do? We want to increase it or decrease it. So we say plus equal or minus equal. Plus equal means we want to plus equal that by a vector. And we want to implement some kind of a, let's say, speed. For example, we're going to have a float here, speed. It's literally our movement speed. And we can define this, let's say, by 2. Or 3 or 5, I don't know. It depends. We'll see in a moment. So we want to increase the transform position. Literally, we only want to check or change the x-axis. Because we are moving over here to the right. Or in this case, we move to the left. So we need to negate it. So we want to say negative or minus. There's one more thing we need to consider is the I believe we have done it correct by creating this cube first where the player is sticking on, because the Z value on this needs to look not in our direction but in away from the camera, because otherwise the object might act in the opposite way. So we say we want to negate our current transform position, the current position of our player. We want to negate it by, and now we need to say vector 3. I would try left times our speed. And we need to do the opposite for the right one. So we need to say plus vector 3 left, or we might be able to go with vector 3 dot right times speed. And since we want to have it rather smoothly, we also say dot time dot delta. So plus, oh no, we multiply times time dot delta time over here. Time dot delta time. This is just to have every it's literally, it's for synchronizing, maybe kind of. It's maybe not maybe. It is doing it so that every, let's say, module or every smartphone or any other device is going to use the same speed. So it's flattening or maybe smoothing out the speed over here. Don't forget to save. Control S for quick save. Gonna make my beautiful painting away and let the compiler run and see if we have any issues with that. If so, the console will tell us. So I have the player script over here. I haven't done anything but that. I press play now, and now when I click the mouse key and hold it down and move my mouse to the left, you can see it is sliding to the left. If I do the opposite, well, both directions do the same. That's funny. So we need to fix that. So maybe we need to say here plus left and here plus right. Otherwise the negation doesn't really work, I guess. Let's try again. Because the left side has a -1 input over here and vice versa. So let's try again. We push left, we push right, left, right. Pretty nice. So now we have like a mouse touch input and it moves. Meanwhile, we hold down, or I hold down. When I let go, then you can see it doesn't do anything. Cool. Now we want to make it a bit more phenomenal. Let's put a 10 over here just to see what's going on. Maybe we want to translate that even different later on. Oh, For example, we can do something like move to the position, a relative position to the mouse. So don't move further than you can put your finger on, because otherwise we may lose the actual player. But that way, depending on where we are dragging and where we have selected the first time, we are able to move our character or our player left and right. Now we need a bit more, or I want it to be a bit more. I want to translate some rotation here as well. But in that case, we want to make sure that we don't overdo it. Maybe there's a way so we can wrap the rotation up until a specific angle. But that is not too bad at all. Before we do this, I want to go for a legit move. So I want to shoot raycasts to the left and to the right, so we are unable to leave the actual playfield. So how does it work? Well, whenever we hold down the mouse key, we can say we wanna have a raycast shooting into two directions. So we need two raycasts, two raycast hits, and two responses. Is there a wall to the left? Yes, no. Is there a wall to the right? Yes, no. If that is the case, we're gonna have a valid move. So we can shoot these rays 2 times or multiple times. Like we can create multiple rays into multiple directions. Of course, this is going to be a bit more code heavy, because each direction needs its own ray, its own check, literally, even if they do the same thing. We can also create this check at the same time, or like in one function. So it could say something like it just returns true or false. Let's create such a function. We want to return true or false. Is there a wall or is there no wall? And yesterday in the CHOOCHO-Rocket, we were using this same technique to see or look forward if there is a wall, and if so, then we did a decision change. If you want to look forward or want to check out the CHOOCHO-Rocket 1, the CHOOCHO, I don't know what I called it, CHOOCHO-Rocket, you're gonna find it once you check my channel out. We used the same one. We want to check if we got a valid move. The valid move in this case is going to be, is there a wall left or right? Yes, no. If that is the case, then we want to return true. Otherwise, we want to return false. So we now want to shoot 2 rays. So we need a ray left. So I name it ray L. Where do I want to shoot it from and to? So first of all, we create this new ray. And we can now define the origin, which is the transform position of the player. So the transformed position, that's the origin point. This is the point where the ray starts to shoot from. Then we say comma, and then here we want to shoot a direction. And the direction over here could be 2 things. We could use the relative position. So in this case, transform dot. Let's use left. But as you can see, transform left is not effective over here. So we need to use transform right, but we need to negate it. We say negative transform dot right is going to be automatically the left direction. This is the local transform. It's not the world space transform. Don't forget this. So in that case, if that is the local one, then it should be negative transform right. We close the line with a semicolon. Now we create a second ray for the right side. It's literally the same without the minus over here. I'm going to rename this one to be ray R. So we create 2 rays at the same time by checking for a valid move left and right at the same time. Now we need a raycast hit. Literally 2 again. So we need to have a hit L. We probably can use a comma here and a hit R. So far so good. Now we go for the physics check. We need to do 2 physics checks for the left side as well as for the right side. So we can do something like if physics.raycast